Hey everyone, let's look at this problem where we are trying to find a net force on charge number 3. We have 3 charges here and we are given each charge. We have Q1 which is positive, Q2 which is negative, and Q3 which is positive. The first step is to draw the forces on Q3. We know that there's a force between charges 1 and 3, and since like charges repel each other, we can draw that force as a repulsive force. It's going to point away from Q1 because Q3 is repelled by Q1. We draw the force at Q3 because we are looking for the forces on Q3. We're also going to label this force. I'll label it F13 to represent the force due to charge number 1 acting on charge number 3. And then let's go ahead and label the other force. We have a force between charges 2 and 3. Opposite charges attract each other, so Q3 will be attracted to Q2. So we're going to draw a line towards Q2. There should be a straight line here between the two charges. We're going to label this force F23, the force from Q2 acting on Q3. So make sure that both forces are acting on Q3. That's the first part. Now we want to find the magnitude of each force. For that, we're going to use Coulomb's law. So to find F13, we're going to plug in Coulomb's constant, Q1, Q3, and R squared, but we'll call R, which is the distance between the two charges. Instead of calling it R, we'll call it R13, just so that we don't get it mixed up with the other distance for the other force. So R squared, so that means it's R13 squared. Actually, I need to draw a little bit smaller here. All right. And now we can plug in the values. 8.99 times 10 to the 9 for Coulomb's constant. And for the charges, we're just going to put the magnitude of the charge. We don't care about the negative signs because we already know the direction of the forces. We've already drawn the direction. So Q1 is 1.7 times 10 to the negative 6 Coulomb. Q3 is 5 times 10 to the negative 6 coulombs. We're going to divide by that distance, which we can see from the axes here that the distance is 3 centimeters, which we are going to convert to meters. So it's going to be 0.03 meters. Plug all of this in the calculator, and we are going to get 84.91. Hopefully you have a little bit more room than I do here. 84.91 newtons. And then let's do the same thing for the other force, F23. It's going to be the force between Q2 and Q3, and the distance is going to be R23. We're going to square that. So the distance between the two is right here. It's called R23. And since we have a right triangle here, we can use the Pythagorean theorem to find that distance. We're going to say that R23 is equal to the square root of 0.03 squared plus 0.03 squared, the legs of the two triangle. And that's going to give us a distance of 0.0424. That's a 4 right here. Meters. So we can plug that in over here. So 8.99 times 10 to the 9. Q2, we're going to just look at the magnitude of the charge. We don't care about the negative sign. 9.1 times 10 to the negative 6. And then Q3 is 5 times 10 to the negative 6. And then that distance squared, 0.0424 squared. And all of that is going to give us 227.25 newtons. Now in my calculator, I'm keeping all the unrounded values, but I am rounding here on the screen. Now we need to find the x and y components of each force, and then of the resultant force. So what I like to do is create a little table to show the x and y components. And I like to write out each one. So trying to stick to my color scheme here. So F13x, F13y, we're writing down the x and y components of F1, and then we'll do the same for F2, F23x, and F23y. So whenever a force is completely horizontal, that means that it only has an x component. So the x component of F13 is just F13. It's 84.91. We know it's positive because the force is pointing to the right. I'm leaving out the units here, but all of these forces are in newtons. And then, since the force is completely horizontal, that means it does not have a y component, so the y component is 0. And then we can look at the x and y components of F23. We notice that F23 is a diagonal force, so we want to go ahead and draw its components. Because the force is going to the left and upward, we can draw a component going to the left. That's going to be the x component, F23x, and there's going to be a component going upwards, which is F23y. So the x component was going to the left, the y component is going upwards. In order to find these components, we already have the hypotenuse, which is F23, but we need the angle here. It turns out in this problem that since the legs of the right triangle are the same size, that means that this angle here, just like this one up here, both of these angles are 45 degrees. So that makes our life a little bit easier that we don't have to calculate this angle. If we did have to calculate the angle, then we could just use the inverse tangent of the opposite side, which would be 3, divided by the adjacent side, which would also be 3. So the x component is pointing to the left, so we know it's negative, and it's adjacent to the angle, so it uses cosine. So the way we write a component that is adjacent to the angle, we write the hypotenuse first, which is F23, and then cosine of the angle. And that's going to give us negative 160.7, where I did plug in F23, which was a 227.25. I did plug that in there. And then F23y, that component is opposite the angle, so it's going to be the hypotenuse, F23, sine of 45. And we're going to get the same value, 160, but it's positive, since cosine and sine of 45 have the same value. So we have found the x and y components of each force. Now we need to go ahead and find the x and y components of the resultant force. To do that, we're going to add our components together in the x direction. That will give us the x component of our resulting force. So we're going to add both of these together. That's going to give us negative 75.8. And we're going to add all of the y components together. That's going to give us the y component of our net force, which is just going to be 160.7. So now what we do is we're going to draw fx and fy tip to tail. We always start by drawing fx. So it's pointing to the left. We don't have to draw it to scale, but we're going to draw it pointing to the left. Then at the tip, we're going to draw fy, which is positive, so it's going to be going up here. And I'm just changing my labeling here so that it's not in the way of the triangle. And then the reason that we do that is because it shows us that F, our net force, is from the beginning to the ending point, the tail of Fx to the tip of Fy. That's our net force right here. That's the direction of the net force, and also known as the resultant force. we need to find the magnitude and direction of this net force. We need to find a magnitude by using the Pythagorean theorem, and we need to find a direction by finding this angle theta. So let's find the magnitude by using the Pythagorean theorem. The net force is going to equal the square root of fx squared plus fy squared. Remember that you don't have to put any negatives in the calculator because they're going to become positive anyway once you square them. So we're going to plug both of these values squared in the calculator into this equation, and that will give us 177.7. And I have not rounded for this, so this is the actual final answer. You can definitely round it to 178 if you would like. And then to find an angle, we're going to use the inverse tan of the y component over the x component. Once again, you're going to plug these two values into here. Make sure your calculator is in degree mode. Do not need to put any negatives in here. This is supposed to say inverse tan here, tan -1. And that's going to give us an angle of 64.8 degrees. Now, note that this is not our final answer because we know the force is going to the left and upward. We found this angle here. So what we can say is we can say that this angle here is above the negative x-axis. We could say that if we wanted to, because we can visualize that right here we have the x and y axes, so this would be the negative x-axis that it's above here. Or we can just provide the angle with respect to the positive x-axis. That's what we usually do. We can go ahead and provide this angle right here. Call it phi, just to not confuse the two angles. And the phi is just going to be 180 minus theta, since the whole axis here is 180 degrees. So that's going to give us 115.2 degrees. So either answer is acceptable. Hopefully this was helpful, and see you in class.